In this video, I'll be showing you how to write world space information to a render target and then retrieve that information using the materials. I've used this technique to reveal and hide parts of my level in a couple of my previous projects. I really enjoy this mechanic and I think it's worth taking a look at. I'm the Undead Dev and welcome to my channel. So as I said, I've used this technique in a couple of my previous projects. I've used it in a game called Painting with Death, where the player can paint things either alive or dead. So it just allows you to paint directly onto the terrain. And in order to do that, I needed to check where the player was painting and change how the world acted based on where the player had painted. I also used this in a game called Where Am I, which is a project that has not seen the light of day yet, where the players could paint in and hide parts of the world in order to complete puzzles. I personally really like this effect. If you ever played American McGee's Grimm, I feel like they used a very similar effect in order to show where you had and had not been. And you can do a lot of stuff with this. The real strength is that you allow the player to affect the world in ways that most games don't. I really enjoy as a player the creative freedom to be able to paint into the landscape and see how I change the world. This effect is also really useful if you need to keep track of locations players have done things. I've seen this effect used for footprints in snow or in mud. Basically anything where you need to store where a player has been or change the landscape based on some sort of information. I find that it's an interesting technique with a lot of applications. So let me show you how I pull it off. So before we get into the tutorial, let me show you what we'll be building. I called this a vanishing effect, but it's going to be much more of a revealing effect than it is a vanishing effect, at least for this video. You can write to the render target either zeros or ones. If you write ones to the render target, you'll be revealing stuff. If you write zeros, you'll be able to make it vanish. So let me show you the final effect in practice. So as you can see, as my player is running around, I'm revealing parts of the level that were there the whole time. But they don't show up until I get close enough. And once I get close enough, they stay there because I've written information to a render target in order to show them. But this is the effect in action here. So in order to pull this off, let's jump into the tutorial. So to start, I'm using the basic map template. I've updated the floor cube by scaling it 100 in every direction. As usual, I've created a custom folder in the content root of the project, and I've created folders inside that for maps, blueprints, and materials. First, we'll create the render target. We'll create it using a canvas render target 2D, which is slightly easier to write to than the standard render target, and we'll name it RT Vanishing Effect. Now we'll need an actor that can handle interactions with the render target. It'll be a standard actor and we'll call it BP Vanishing Effect Handler. Now we'll need to create a material that will use the render target. I'll just call this Matte Vanishing Effect. Let's first update the material by plugging the render target directly into the base color and then applying the material to the floor. Now, in the Effect Handler actor, let's add a reference to the render target by creating a variable of type renderTargetCanvas, and we'll call this Effect Render Target. Next, compile so that we get the option to add default values, and add the render target we created as the default value for that variable. We'll create a new function called drawWorldLocation to render target. Let's have it take in a vector called worldLocation. This function will handle all of the translation between the world locations and the spot on the render target that corresponds to that location. To begin drawing to the canvas, we'll call begin_draw_canvas to render target. We'll add a draw polygon call. Most of the stuff we can leave alone. We will set the side num count to 100, which will make it pretty close to a circle for all intents and purposes. Now we know the location will need to be translated to the right coordinate system for the render target, but let's not worry about that just yet. We'll break the location into its components and wire X and Y to the screen position X and Y. We also need to add a call to clear render target 2D from the begin play event. This is because once we write to render target, it stays written to, even after you end the debug session. In order to start with a clean slate each time, we need to wipe the render target when we start. Now we have a function that will write to the render target, but we don't have anything yet that actually calls that function. Let's create an actor component to call that function. We'll make it an actor component so that it can be added to any actor in the game. This makes the code reusable. We'll call this component AC Effect Writer. AC for actor component. And we'll make this class really simple. On begin play, we will capture a reference to the vanishing effect handler we created before and save it as a variable for later. And then on tick, we will get the location of the actor we attach this component to and send that to the handler. Note that I am adding it to tick for the purpose of this tutorial, but in an actual game, it might be good to move it to an event or a timer or something other than ticking every single frame. Now, I can just add a sphere static mesh actor to the scene and drag a component onto it. I'll add a text renderer component too, just to label it a little clearer. Don't forget to also add a copy of the effect handler actor to the scene or this won't work. And ta-da! The area directly under the effect writer has changed color. Well, kind of. You'll notice if I move the writer even a little, it stops working. The reason is because we haven't done any of the coordinate system translations yet. It only worked the first time because the sphere static mesh was at the 00XY location in world space, and conveniently 00 is all of the coordinate systems we have to deal with. So now we need to think about how we can convert different coordinate systems to work together. First, we need to think about how much of the 3D world we want to care about. The world spans out for nearly an infinite distance, but there is a limited amount of space on the render target. So I'm going to add a cube to the render target to help me visualize exactly how big the area I'm working with actually is. I've created an effect range X and an effect range Y variable. We'll use these variables to do our transformation. I've also added a set world scale 3D to the cube in our construction script, so that you can visualize exactly how big these abstract feeling numbers really are. Now note, I've divided both ranges before I set the scale in order to offset the default scale of the cube. Also important to note, the correct number to divide them by is 100, not the 10 you see me dividing it by here. I figured that out later in the recording, but let's fix that here before you get too far. And we'll just set the z to a constant 0.1. I'm going to mark this actor hidden in game so that it doesn't show up while we're playing, but only is visible in the editor. Now, I'm going to quickly create a material for the cube so we can see through it. I'll set the color to green, going to set the blend mode to translucent so that I can see through. I'm also going to run the default Fresnel node to the opacity mask. This has a nice effect of making the main body of the shape really translucent, but making the edges stand out a bit more, which is good for something like this where I want to see through it, but I care about how far it goes and where it ends. Now I'll drag that onto our cube and we'll see it in action. So we've set the extent of how much of the world space we're going to be updating with the handler blueprint. But later on, when we're working in the materials, we won't have access to that information anymore. So we need to store that information someplace easily accessible from the material graph. There's probably a couple of different ways to do this, but I'm going to use a material parameter collection. We'll call this MPC Vanishing Params. Let's open that up, and we're going to add 3 parameters to this collection. First, the X scale and the Y scale that we've already talked about. We'll make both scalar values. And we also need to capture the center location, because height and width are only so helpful if we don't also know where the center of the effect is. By storing all this information, our effect should not be limited to the center of the map. We should be able to move it around once we're done with it. To get access to the material parameter collection, I'm going to create a variable on the Vanish effect handler called effect material parameter collection. And from there, I'll be able to set the individual parameters. Now, I don't plan on moving the effect during gameplay, so I'm just going to set these values once at the begin play event. After the clear render target, I'll just add 1 set vector parameter value node and 2 set scalar parameter value nodes using the parameter names we created in the material parameter collection. So let's look at the first conversion we need to do. We need to be able to take the world coordinates and map those to the render target coordinates. To do this, we will use a handy blueprint node called map range clamped. This will take in 2 sets of ranges and a value and convert the value from one range to the other. In order to use this node, though, we need a max and min for both ranges. We can get the max and min of the render target from the render target itself. But for the max and min values of the world space coordinates, we will need to compute those. I'll create a separate min-max function on the effect handler to help keep our code clean. We'll make that a pure function because it's only getting values. That way it won't require an execution pin. We can calculate the min and max values by splitting the range in half and then adding it or subtracting it from the center location, which in this case we're using the actor's location. And then we just feed those back in through the return node. So now, if we go back to the draw world location to render target function, we can update it to do the actual conversion. From the begin draw canvas to render target node, we can break the size vector into its components for our maximum X and Y values. Then if we also break the max and min and the world location, we can map all the X values in one node and all the Y values in the other. For each of these, the range A will be the minimum and the range B will be the maximum. And we will be mapping from world space to render targets, so we will use the min-max that we calculated for the in values and the render target size for the out values. And of course, we'll use the world location for the value inputs. Now we need to handle the next translation step, extracting the data from the render target and using it back in the world space. The most effective approach I've found is to map the world coordinates into UV space, which the sampler can then read from the render target texture in the sample texture node. So here's how we do that, and it's actually very similar to what we did in the original world space translation. Again, we are going to use a remap node, but in materials, this node is called remap value range normalized. If you drag the material parameter collection into the material graph, it will create a node to access the param we want by name. So we'll do that 3 times to get all 3 parameters that we stored. The remap value range normalized node only works with scalar values, meaning we can't feed both the X and Y values to the node at the same time and have it work. So we'll need to use the mask node to filter out just one value at a time and then duplicate the code for the X and the Y values. Note that we are in materials, so we don't have an X and a Y and a Z. Instead, we have an R, a G, and a B. So if you want the X value, call it R, and if you want the Y value, we call it G. This will get a little messy, but I'll try and keep this as clean as possible. Once again, in order to get the min and max values that we will be mapping from, we'll take the center location and either add or subtract half the total width or height, respectively. You may notice that unlike the blueprint remap node that we used earlier, this node has no output range. That's because the range is normalized, and when a value is normalized in a material, that's just the equivalent of saying it's mapped between the ranges of 0 and 1. And as we are trying to map this to UV space, which goes from 0 to 1, this is exactly what we want anyway. So now I've copied and pasted this for each of the axes, and then appended them back together to be a vector using the append node. Quick note, you'll see here that I have updated the material to use a lerp node to transition from black to an emissive red color depending on if the target has been written to. That was done off screen while I was debugging something that wasn't working. So I just wanted to call that out so you aren't confused as to why things look different all of a sudden. Now you can see that as I move the sphere in different directions, it works up until a point, then it just shoots off into infinity. And that's because I hit the edge of the area we were looking at. Earlier when I mentioned that you need to scale the cube for our preview by 100 instead of 10, that's the cause of my issue here. The preview mesh is much bigger than the actual area that we're using. So now if I just change the preview mesh scale, and I update the actual scale of the area we're looking at to a much larger area, you can see this starts working a lot better. So now we have the sphere directly altering the render target, which is in turn directly altering the ground texture. But the sphere isn't really all that interesting. We added the component to the sphere so that we can add it to anything. Let's go ahead and add it to our first-person blueprint. Now we have the ability to run around and actually change the game we're in, which is pretty cool. So to make this appearing or vanishing effect we want, all we need to do is take the output of the lerp and feed it directly into the opacity mask for the material we're working on. And there you go. Now if you hit play, you can run around revealing the land underneath your character as you get closer to it. And now that we've got this part working, let's refactor the material just a little bit. Let's take the UV math that we did in the render target, and let's go ahead and make a material function so that it can be reused again in other materials. Let's copy everything up to and including the render target. And if we right click on the content browser and go to Material Advanced, you'll see Material Function. We'll create a new material function called MF Vanishing Effect and paste everything into that material function. Wire up the output of what we just copied to the output node and we should be good. Now we have a material function that can be added into any other material and have it work. So now let's go back to the vanishing effect material we had, delete everything in it, and just copy the material function we created and run the output to the opacity mask. And as you can see, everything's still working the way it was before. Let's go ahead and try this on a different level so there's more interesting things we can reveal. So now we're on level first person. This is the map that comes with the first person template. The first thing we need to do is drag the BP vanishing effect handler onto this map. So now we just need to extend the width and height such that the preview mesh is over everything in this map, so that we're accounting for all of it. I'm going to place the center right above the center of the map. Luckily enough, there's only 2 real materials being used here, so it'll be pretty easy to update this level to work in our system. The materials being used in this level are engine content materials, and I don't want to change those. So what I'm going to do is find the master material that each one of these material instances belongs to, and make a copy that I can put in our custom materials folder. And you can do that easily by just clicking on a mesh that the material's on, then browse to Asset, and then right-click and go to Parent Material. If you do that enough times, it'll take you to the master material that the material comes from. Then you can just click and drag those into your custom material folder, and it'll ask if you want to move the material or copy to folder. And you always want to create a copy. Never change things that are in engine content. You can break things. So then if you go into the material and change the blend mode from opaque to mask, it'll allow you to add an opacity mask to the material. Then we'll just feed our material function into that opacity mask. We'll do that for both materials. And then we just need to drag and drop our new materials onto the assets in this level. You'll notice that as I drag the materials onto these meshes, they disappear. And that's because the render target is currently empty, so the opacity for the material is currently nothing. And there you have it. Now you can run around revealing the map as you go. So this kind of shows how you can easily add these pieces to existing things or to build them in from the start and make all kinds of props and things that will react to these render targets. I find this to be a really fun and interesting mechanic. And I hope you see kind of the potential for this as well. And that's the basic idea. I may do another video where I go in a little bit more in depth on some of the other kind of edge cases and things you can do with this. And that's it. There's a lot you can do with this. There's a lot of different effects you can apply to this. I've just shown you here how you can vanish or reveal the world, but in my game, Painting with Death, I use it to either kill or bring things to life. There's a lot of really cool stuff you can do. I highly recommend you play with it, you find out what works for you, and most of all, have fun. If you found this video helpful, this is your reminder to like and subscribe. Thank you for taking the time to watch my tutorial.